Welcome friends to the class of marketing research and analysis. In the last lecture we had started with multiple regression. So, we understand now that multiple regression is helpful for prediction or predicting some outcome, right, where the outcome is dependent on certain independent variables also called as the predictors. Okay. So, the effect of these independent variables or the predictors on the dependent variable is of our interest to always measure in any research study, right. That means, what I mean to say is there are suppose 3 variables or 2 variables, and we want to see the effect of these 2 variables on the dependent variable, and we want to see which one of them x1 and x2 suppose are the independent variables, then whether x1 has a larger impact on the dependent variable y or x2 has a larger impact on the dependent variable y. So, these are things that is of interest, right. And then we also would like to know how much x1 and x2 are explaining the dependent variable and how much is left as the unexplained variance, which is called as the error or residual. Okay. So, there while discussing about multiple regression, I remember we had discussed about a concept called multicollinearity. So, we said the presence of multicollinearity, which is generally very generally not which comes from by understanding that if there is a high correlation among the independent variables, generally about 0.9 or so, generally speaking, right, then a problem of multicollinearity exists. But there are also instances when the combined effect of certain variables does have an effect of multicollinearity. So, in that case we can see that even a poor correlation, that means not a very high correlation as high as 0.9, but even a correlation of 0.6 or 7 can also have a multicollinearity issue, right. So, to do that I explained how to check that, how to measure that multicollinearity problem through techniques like variance inflation factor called VIF or tolerance, right, and how to calculate that also I had explained in the last lecture. So, today we will be continuing from there and trying to solve a few problems and also doing it in the SPSS, right. This is a concept of multiple regression. So, there are 2 types of multiple regression basically we will talk of. One is the standard multiple regression, right, and the other is the hierarchical multiple regression. What is this hierarchical regression and what is the standard multiple regression? The standard multiple regression is a type of regression which assumes that all the variables are equally important and there is nothing to be controlled, right. But in the hierarchical multiple regression, on the other hand, we are trying to create blocks and trying to control certain variables and trying to see then the effect of this control by effect on the independent variable. That means, when I am controlling a variable and using other suppose there are 3 variables, suppose I am controlling x1 and leaving x2 and x3, then what is the effect on the dependent variable, and once I take all the 3 variables together, what is the effect on the dependent variable. So, when I see such effects, so that helps me to understand the effect of individually the variables. Okay. So, let us start with the standard multiple regression. Okay. So, here all the independent variables are entered into the equation simultaneously. So, as I said, like in the hierarchical regression you do it in a block form. So, there is nothing like it here. So, all the IVs are entered simultaneously, right. The amount of variance in the dependent variable is explained by this set of independent variables, but I had explained you, I had warned you that you should be careful of the problem of multicollinearity, right, multicollinearity. You should always check it. If you do not check and there is a presence of multicollinearity, what will happen? Maybe you will have very insignificant beta weights and you can have your hypothesis that some independent variable is influencing the dependent variable might come wrong, right. So, this is what will happen. Then it helps in identifying the strongest predictor variable or the strongest, this is the independent variable within the model. Suppose you have x1, x2, x3 which have an effect on the y. Now, out of this which one has the largest impact, that can be measured with the help of this standard multiple regression. Let us take this case, we will solve this problem. This is a numerical problem, we will solve it by hand. A company wants to know how the food and water intake of employees determine the performance in their job. So, the company is bothered or is interested to know how is the performance in the job connected with the intake of food and water. That means, does sometimes we also know that after your lunch, your efficiency goes down, right. You tend to, your body also starts using this energy for digestion and all. So, you become lethargic, you tend to sleep and something. But if your water intake is low, right, on the other hand inverse relationship, then you might be dehydrated and your energy, your body will start trying to save the energy. So, in that case water intake should be high and also not very high that you frequently visit the washroom maybe or the loo, and food intake should not be very high on the other hand. So, it should not, this one should not be very high and this one should not be very low to dehydrate you, right. So, we want to see how this affects the job performance, right, and let us see this case. Okay. So, how do you do this? So, I have x1 food, x2 is water, performance is my y, right. So, these are all the values that you see. So, summation of x1 is 30, summation of x2 is 60, summation of y is 120. Now, x1 minus x1 bar. So, if I show you the formula first, why do I do it? So, this is the formula, how do I measure? So, you remember that when in any regression, in a simple regression, we had this things to which we needed to calculate, a which is my intercept, then I needed a b, right, slope. So, I needed this slope and intercept in a simple regression, intercept, right. But during a multiple regression, suppose there are two variables, then I will have a, b1 and b2, right. So, now I need to calculate this b1 and b2, right. So, how is this b1 calculated? It says sum of product of x1 into y. So, sum of SS is sum of square of x2 minus, right, sum of product of x1 and x2. So, here it was x1 and y, here x1 and x2 into sum of product of x2 and y divided by overall sum of square of x1 into sum of square of x2 minus sum of product of x1 x2 into sum of product of x1 x2, right. So, when we do this, we will require these values. For example, you see sum of product of x1 y. So, x1 into y. So, here we are taking x1 as x1 minus x1 bar. So, this is the mean, right. So, the observed value minus the mean, the summation of it, y. So, for y we are taking y minus y bar, right, into, so into sum of square of what, x2. So, x2 minus x2 bar mean, so square, because it is only sum of square of the x2 minus, so this minus, right, sum of product of x1 x2. So, sum of product x1 first. So, x1 is x1 minus x1 bar into x2, x2 into x2 minus x2 bar. So, this one is this part, right, up to this much, then into which comes here is sum of product of x2 y. So, x2 is x2 minus x2 bar into y is y minus y bar divided by similarly sum of square of x1. What it will be? X1 is x1 minus x1 bar, since it is a square, sum of square, it is square into sum of square of x2. So, x2 minus x2 bar square, right. Now, this minus comes here, sum of product of x1 and x2. So, x1 will be x1 minus x1 bar into x2 will be x2 minus x2 bar, right, into this into, right, x1 x2. So, x1 minus x1 bar into again x2 minus x2 bar. So, when I do this, so for that I have to calculate. Now, let me go back. So, x1 minus x1 bar, x2 minus x2 bar, y minus y bar, x1 minus x1 bar square of it, right, x2 minus x2 bar square. Now, x1 minus x1 bar into x2 minus x2 bar, right, x1 minus x1 bar into y minus y bar, x2 minus x2 bar, y minus y bar. These are all we require. So, when we did this, we have found out all the values. Okay. So, now x1 summation of x is 30. So, summation of mean of x1 is how much? 6. x2 is summation of x2 is 60. So, divided by 5, n is 5. So, 12. Summation of mean of y is summation of y divided by n. So, how much? Now, 120. 120 divided by 5. I have forgotten to write it. So, n is 5. So, that is equal to 24. Okay. So, all the 3 we have got. Now, let us use this. Now, when I use this formula, put it in the formula, how much am I getting? x1 minus x1 bar. Let us go back. So, how much is it? So, x1 minus x 1 bar into y minus y bar, you require this value, right. So, this part is how much 43, right. Then x 2 minus x 2 bar square. So, x 2 minus x 2 bar square, this one, right. So, this is 40, right. Then x 1 minus x 1 bar into x 2 minus x 2 bar, right, x 1 this one, right, is 19, and x 2 minus x 2 bar into y minus y bar, x 2 this one, right, is how much 77. So, 77. Then putting similarly the at the below x 1 minus x 1 bar square, x 1 minus x 1 bar x 1 minus x 1 bar square. So, this one 10, right. So, 10 into 40, again we have seen it here from here, x 2 minus x 2 bar is 40, and 19, so we have already got it here. So, now taking this, right, 19 into 19. So, because it is the 2. So, B 1 we are getting is 6.58974. So, we have calculated B 1. Similarly, you can calculate for B 2. Now, just see the difference between the formulas. Here x 1 y, here x 2 y, here x 1, here x 2, right. This is same. Now, this one is x 2 y here, here it will be x 1 y, and other things also slightly, if you use your little slowly your logic, you can understand the changes and you can make the formula, right. So, SS x 1 into SS x 2, SP sum of product of x 1 x 2 twice. So, now this value we have got is minus 1.2053. So, now we have got B 1, we have got B 2, right. Now, A we know is equal to how much? A is equal to y bar minus B 1 x 1 minus B 2 x 2. Now, this is how it is come from here, A y is equal to A plus B 1 x 1 plus B 2 x 2, correct. So, if I take it this side, this is what I am getting, A is equal to minus B 1 x 1 y minus B 1 x 1 minus B 2 x 2. So, doing this we have seen y bar was how much? Y bar was 24, okay. So, putting this formula we have got A is equal to this much. So, now what is our estimated y? So, estimated y is y is equal to, now putting this, A is equal to how much? A is equal to this much minus 1.06792, right. So, plus B 1 x 1. So, B 1 is how much? B 1 is 6.58974, right, x 1 minus, obviously you will get 1.2, this was minus. So, minus 1 x 2. So, now if you get a value of x 1 and x 2, then you can easily calculate for y, right. So, interpretation, the result confirmed a significant influence of food and water intake on job performance. I will show you this, I have brought a data set with me, but let me show you one more way of conducting multiple regression, then I will show you that, right. So, this is a very simple method, you just need to understand it, you can do. The next, there is one more problem I have brought. So, this is what it is saying is, a personal psychologist who is working for Tata Motors, the company wants to develop a recruitment process that will help them identify job applicants who will be the most productive employees. Okay. 5 currently employed employees were chosen and detailed information was collected. What information? Now, their school, how much highest year of school completed, what is the motivation level on a motivation scale, it has been measured, and how much they are earning in dollars, that has been measured, right. Not earning, this will be how much they are helping in the sales, right. So, the mean, standard deviation and correlations are given. So, highest year of school, the mean is 15, motivation is 45.54, the mean for motivation, and the sales mean is this much. The standard deviation is also given to you. Now, correlation between highest year of school and motivation are x 1 x 2, let us see, are x 1 and x 2, school and motivation, right, is this much. Correlation between year of school and sales, right, is this much, and the third, correlation between motivation and annual sales is this much, right. So, this I think I am sure you can calculate if you have followed my last lecture, where we have where I have shown how to calculate by hand the correlation values between two variables. Okay. So, you can calculate. Now, using these values we will see. So, what is the formula for R? What is the R? The multiple correlation. Now, what is the formula? Now, the correlation between y and x 1 square plus the correlation between y and x 2 square minus 2 the correlation between y and x 1, the correlation into the correlation between y and x2 and the correlation between x1 and x2, right, divided by 1 minus the correlation, the square of the correlation between x1 and x2, right. If I do this, I am getting the R value as 60. Now, since our multiple correlation is 0.930, so you can understand if R is this much, what will be my R square, you can measure, which is my, this is my relation correlation, this is my determination, right. So, my R square is will be 9 9s are 81, something around 8384, correct. In other words, we could make a very accurate prediction about how much money, not a salesperson, sorry, this is this employee, right, employee will bring if we know nothing more about the person than their education and their score on a motivation scale. So, if I know the motivation level and the person's school or year of education, then I can say how much annual sales they can bring into the company, the Tata Motors, right. So, what it says, making predictions using multiple regression. Through the results of R, we have a measure that allows us to establish whether or not our independent variables are effective predictors of our dependent variable. Now, we can take the next step and actually use our knowledge to make predictions. So, y is equal to this much, this is the formula. So, prediction, so y is equal to a predicted value of y, a is the intercept, b1 the change of in y for each one increment change in x1. So, in our case this is the highest year of school, right, school was the x1. B2 is the change in y, this is very important, you need to reread it and understand, this is very simple but very important. The change in y for each one increment change in x2, that means here in this case the x2 was kept constant, x2 was constant, in this case the x1 is constant, okay, this is the meaning. X is equal to an x score for which you are trying to predict a value of y, okay. Now, how to calculate this B1 B2, this formula? Now, we have, right, now B1 is equal to, this is the formula, if you use, this is the standard deviation, all the notations are given. So, R y x1 is the correlation between highest year of education and annual sales. Why? Because y is my sales, x1 is my education, minus R relation between y sales and x2 is my motivation into education and motivation into and divided by this, right, 1 minus education and motivation square into the standard deviation of y, that is sales, divided by the standard deviation of x1. Why? Because we are measuring for B1. So, since we are measuring for x1, so since we are measuring B1, so we will be using x1, right. For B2 we will be using x2, right. So, when we use this formula, this is another way also you can do it through the correlation, right. So, if you use this, so how much is the B1 in this case we have got, so B1 by putting into this formula, right, we have got 34,356. Similarly, B2 is minus 3,657, okay. So, if I use and now calculate A by using the same formula y is equal to A plus B1 x1 plus B2 x2. So, y minus now A is equal to y minus B1 x1 minus B2 x2, right. Since x1 and x2 only means are known to us, we will use them, right. So, all the three means, right. So, then we have, by using this we have calculated A is equal to 60,049, okay. So, now if I put the values into the formula, how it will look, A plus B1, right, B1 x1 plus this is the minus value. So, minus B2, that means B2 value whatever it is into x2. Now, whatever now x1 and x2, so whatever the education level and the motivation level are there, if you know about a new employee, then you can predict that how much of sales will happen due to this particular employee, right. So, this is what multiple regression helps you to do. So, we have done this by hand. Now, I will explain you how to do it in the SPSS. So, let us understand this case. A health researcher wants to establish or wants to be able to predict VO2 max. Now, this earlier also we had used this case. VO2 is basically utilizing the oxygen or the ability of a body to utilize oxygen during intense situations, which is an indicator of fitness and health. So, normally to perform this procedure, expensive laboratory equipments are required, right. So, this is the case where 100 participants have been taken to perform a maximum VO2 maximum test, okay. their age, weight, heart rate and gender was recorded to just see if gender influenced the VO2 utilization, if heart rate affected it, if weight affected it, if age affected it, right. Heart rate is the average of the last 5 minutes of a 20-minute much easier lower workload cycling test. Heart rate has been measured that way. The researcher's goal is to be able to predict maximum oxygen utility based on these 4 attributes. Okay. Now, let us see this case. Now, how do you do it? Now, I am going straight away to the multiple regression case, right. Okay. So, how you should do it? So, I will show you through another example in this case. So, this is how you take it to the regression. So, that problem also you can understand. So, you see the VO2 max was taken as a dependent variable and other things were taken as my independent variable. Okay. So, all the steps are explained to you in this case, right. So, what do I want? Estimates, model fit, R square change, you can also take this R square change, right. Even you can check the collinearity diagnosis in case there is some multicollinearity problem, right. To check that you can take it, descriptives also you can use, right. Now, this was which I had done at my on my own. So, the first table of interest, this was a table which I through the data which I had, when I calculated I found the data that I had was the R square, R was coming 0.76 and thus the R square was square of it. So, 0.77, standard error of estimate is 0.69, right. So, the R column, it represents the value of R, the multiple correlation coefficient. R can be considered to be one measure of the quality of the prediction of the dependent variable. So, as you understand R square, what is R square? R square is the explained variance, that means in this case 57 minus 1 minus 0.77, how much is it? 0.577 is equal to let us say 0.42, almost 0.42. So, 42% is unexplained, which is the error, is equal to unexplained is equal to which is called as error, and 57% is only explained in this case. Okay. How do you interpret these results? So, a value of 0.760 in this example indicates a good level of prediction, right. The R square called the coefficient of determination is the proportion of variance in the dependent variable that can be explained by the independent variables, right. Okay. You can see from our here this case it says that our independent variables explain 57.7%. Okay. Now, how do you interpret the output? The F ratio in the ANOVA table, you get an ANOVA table which I will show you when I do a test, right. So, shows that the overall regression model is a good fit. Now, if your data is something like this, suppose this is your table, ANOVA table, now is a good fit. Why? Because it is coming significant, right. The table shows that the independent variables statistically significantly predict the dependent variable at what level? Now, the F value at 4 and 95, 4 and 95. Now, I think you are by now you have attended all my lectures, if you have seriously seen it, this 4 and 95 are from what? This 4 is from my between the variance between the group, the variance between the group, right, divided by 95 is my within, right, within. So, this is the between by within, the F ratio is equal to F ratio, right, mean sum of square between, mean sum of square within, right, is my F ratio. So, F 495 is equal to how much? 32.9339 sorry, and significant at a level of 0.005, right. So, this is how you should report, right. Now, look at this continues, if you look at the beta coefficients. Now, what it is saying? What is the beta coefficient? Is that basically the B1, B2 the slopes, right. The unstandardized coefficients, there are two things that when you will see use SPSS or something, you will be reporting two things, you will be seeing two things, sorry. One is the unstandardized and the other is standardized. Now, unstandardized coefficients basically are when the raw data is being used, and standardized is to in fact is standardized in a way so that the mean is 0 and standard deviation is 1. So, that now every variable can be compared with each other, right. So, unstandardized coefficient indicate how much the dependent variable varies with an independent variable when all other independent variables are held constant. So, this is the beauty of regression, that you are trying to see the effect of one variable keeping the others constant. Consider the effect of age in this example. The unstandardized coefficient B1, now age, let us go for age, right, this one, right. for age is equal to how much? 0.165, the unstandardized, right. This means that for each 1 year increase in age there is a decrease. Why? Because minus, right. VO2 max of 0.165 milliliter per minute per kg. This is what it understands. If similarly weight increases by 1 kilo, then minus 0.385 is the change in the VO2 utilization. Similarly the other things, but if gender is increasing, so I do not know what was 0 and what is 1. So, let us say 0 is female and 1 is male. So, males, that means will utilize better the oxygen in comparison to females, right. Now, look at this table also, statistical significance of the independent variables. You can test for the statistical significance of each of the independent variables. Now, how? Now, we have taken this. Now, look at this column, right. So, these two columns. Now, T is equal to minus 2.63 for age, minus 8.87, 3, and all are above, you can see 2. So, if it is above 2, you can be very sure that it will be significant, right. So, what it says, you can test. Now, you can see that this tests whether the unstandardized coefficients or standardized coefficients are equal to 0 in the population. If P is less than 0.05, you can conclude that the coefficients are statistically significant, which is happening in our case. The T value and corresponding P value are located in this column, right. So, finally when you write in your research report, you should like this. A multiple regression was run to predict this from gender, age, weight and heart rate. These variables statistically significantly predicted VO2 maximum, you should write like this, and this one, and the R square is this one. Are all 4 variables added statistically significant to the prediction at this level? If suppose some of them would not have been significant, then you should have written that and you can also write from here. You see, if you look at it, if you look at these values, which one has the highest contribution, if you see now minus 8 this one 9.824, then a gender has the highest, then followed by weight, then followed by heart rate and then followed by age, right. This is what it says. Now, let us do one problem which I have brought for you. So, this is a case for the first example which we have done. I have not brought the data set for the second one. So, this is the first one. So, food and water influencing the performance. So, how do I do? Go to analyze, go to regression, right. So, I need it is a linear regression. What is my dependent variable? Performance. What are my independent variables? Food and water. So, now I want to see how they are affecting. So, you see there is some methods here, stepwise, remove, backward, forward, but I am not doing anything at the moment, I am just doing a enter. That means all the independent variables are taken simultaneously. If I use a forward or a backward, it will be taken in different manners. For example, in forward 1 by 1 it will be adding, in backward all the independent variables will be taken at one go and then they will be eliminated 1 by 1, right. Statistics, now I go to the statistics, I want to see the estimates and the model fit, right. I may use the descriptives for my requirement. If I want to check for multicolority, I can check, right. So, if you have already done it, you may not use it, right. You can use the R square change also, right. So, now let us look at it. So, let us look at the output. So, if you look at the output, right, for example, the performance is 31.8 and with a standard deviation of 7.2, the mean and standard is given. Food, it is given, right. So, there are n is equal to 15, right. Now, look at the correlation. The correlation between let us say performance and food is how much? 0.843, performance and water is 0.908. So, performance is more correlated with water. Food and let us say food and water, for example 0.945 is a very high correlation, right. So, let us see the overall model. If you see R is coming how much, that means these two variables are explaining the performance by 82%. Since the correlation, multiple correlation is 0.91, the R square is 0.82. So, 82% of performance is being explained by these two factors, water and food intake, right, and this is significant, right. Now, looking at the this ANOVA, right. So, if you look at it, this model is overall significant. Now, let us look at food and water individually. Now, if I see here I see one interesting thing is that the food and water, right, in case if you see food and water, out of which the T value for food is very low, that is much below 2, the value of 2, and therefore, and you can see it is non significant. That means, we cannot conclude. What is the null hypothesis in this case? That food has no effect on the performance. And what is my null hypothesis for the second hypothesis? Now, water has no impact on the performance. So, now in some conditions you can use this by you can check even an interaction effect also, which I have not taken, but you can take. For example, in this also I can show you, you can take and check also. For example, compute transform compute variable, I will create a new variable, let us say okay, food, right, into let us say water I am doing, right. So, how do I do? This is food multiplied with okay, water, okay, water. So, this is my new variable, okay. So, I am creating, I think we should give a bracket here, food, I can take FW, leave it FW, right, no issues. So, now I will give okay. Now, a new variable must be created here, you see FW. Now, I want to see the interaction effect also. Now, let me take analyze regression linear, and I will take this variable also here, okay, and let me see whether there is any impact. Let me see if there is any collinearity also I will take, okay. Now, okay, this is not required. Now, look at this new table now. Now, when I took this 3, so what is the relationship of performance and food, performance and water, and the combined effect. Food similarly with this is the combined effect. Now, when I have done and I want to see whether the what is the model impact. First of all, the model has improved, okay, and if I see the VIF, look at the VIF of food, it is 83.73. That means, since there is a very high correlation between food and water, so I need to remove one of them, and I think water had a higher correlation with performance. So, I will remove food, okay. So, if I remove food, it will be a different, and I will show you that also, but let us understand here. Now, if you look at the coefficients, now if you look at the coefficients here, food has improved, earlier it was in a very bad state 0.6 something. Now, water is significant, and the interaction effect is at the moment not showing any impact. But if I do one thing, if I take this and I run it again, let me run it again for you linear, and I take this food out, okay, and I run it. Now, I do not know whether any change will come or not, but I hope there should be some change. Now, you see the inflation the variance inflation factor, this has improved, earlier it was 85 something, it has improved, but the significance has not changed much anyway. So, that does not add anything new to us, but one thing is for sure, we have understood that through a regression equation or through regression, regression helps in predicting, and it helps in predicting the change in the dependent variable due to a change in the independent variable, but this gets highly affected by the presence of the if there is any multicollinearity. In our case there was multicollinearity, so food and water, so that is why it showed a very different kind of result. But okay, anyway, to understand and to write, you can say here from the earlier one, if you omit this part of the interaction part and you take this only, right, if you omit this, right, you can say that well, food has is showing no significant effect on performance, but water does have an effect on performance, and we have also established a relationship for it. Why? We say that the food, once you take the food, then generally one takes food after the lunch time. We have seen that people get drowsy and they get tired, they do not feel like working. So, that drastically adversely affects the performance, but a continuous water intake keeps people dehydrate away from dehydration and keeps them going, right. So, this is something we can logically explain, okay. But anyway, I think you are clear with what is the impact, how to measure multiple regression, what things you should take care of, and how do you explain it and how do you report it. So, well, this is all for the multiple regression, standard multiple regression. In the next lecture, we will talk about the hierarchical regression, how to do a hierarchical regression, and then we will be moving into some other forms of regression, okay. So, thank you very much, have a nice day.